So in these examples, we're going to take a look at some factoring techniques. So in a way, the definition key terms are kind of attached to the problems. So the first rule is called the cube rule, and we just looked at a cube example a second ago when we were doing division, but these are specific cubes that are called either the sum of cubes or the difference of cubes. And if A is a cubed term and B is a cubed term, then the factorization will always be A plus B, meaning the cube root of these terms, and then times A squared minus AB plus B squared. And for a minus, it's the exact same thing, but it's a minus and then two positives. And there's actually a mnemonic device called SOAP to help you with this, and this is how SOAP works. Same sign, so this will be the same sign no matter what. So same sign for addition, but then the O in SOAP is opposite signs, and then the last term is always positive. Same thing here, we have the same sign in our factorization for subtraction, and then the opposite sign, and then always positive. So let's take a look at how this works. All right, so if you think about x to the third power, the cube root of that number would be, what number did I multiply 3 times to get x cubed? So that would be x times x times x. And so the cube root of x is x, meaning A in the formula is x. And B would be the cube root of 27, and 27 is 3 times 3 times 3. So B would be 3. So this factorization is interesting. It's really a, do you recognize that you have the sum of cubes? And then once you do, you just write the formula down and put the answers directly into where they go. So here I'm going to put a parentheses, and I'm going to drop in whatever A is. A is x. Then I'm going to add that to B, right? B is 3, so parentheses 3. Kind of redundant at this point, but they're definitely not redundant in the next step. So here we have parentheses x, because it says to do A squared, and then minus x, and then B, which is 3, and the last one would be plus B squared. And then I actually have to evaluate anything that maybe is a product or an exponent to finish the problem out. So the answer would be x plus 3, meaning the factorization of this problem is x plus 3 times x squared minus 3x plus 9. Always write the coefficient before the variable. So here's a more robust example here. In this case, the cube root of 8x cubed, remember that would really be taking 2x times 2x times 2x. So A would be equal to the cube root of 8x cubed, which is 2x. And then the minus you ignore, because the minus is the formula. That's the whole same sign as the problem, opposite sign, always positive sign. So we're just going to look at 125y cubed. So that would be 5y times 5y times 5y. And so the cube root of 125y cubed is that b is equal to 5y. So my formula, again, I'm just going to write it in here. So my formula is going to be a minus b. I like to use parentheses because students make mistakes by not actually putting things correctly into the algebra step in the second step. And so then we have a parentheses squared, then the same sign here, but then opposite sign, that's the SOAP. So plus a times b, and then always positive sign for the last term, which is also squared. So now we just drop stuff in, right? So here we have 2x. This is also 2x. This is also 2x. Another way of thinking about this is the cube root, that's why I write this out 3 times, of 8x cubed is 2x because there are 3 of them, and you put 3 of them in the formula. So here we have 3 5y's. I'm going to put 3 of them in the formula. And that's why writing the formula down with appropriate parentheses and notation, it's not as cumbersome as you might think. And so then the factorization is this, but that reduces to 2x minus 5y. This is why the parentheses matter, because this will become 2x times 2x, which is 4x squared. 2x times 5y is 10xy. And then 5y squared is 25y squared. All right, so now let's take a look at the next method, which, by the way, this one is probably the hardest. And by the way, this is the only formula you have to memorize in Algebra 2 in the state of Virginia. Everything else is on the formula sheet. So this formula is extremely important to know, and it's the only one you have to memorize. You have to know it by heart on the standard of learning test at the end of the year. So the grouping method basically says that if I have a term where there's a common term here, and then there's a separate common term here, that it will break out with those common terms times whatever is left over. And the best thing to do is just show you how this works. That is the formula, or a version of it. Basically, the way this works is you cut the problem in half. Make sure you include the sign on the third term on the second half of the problem. Do not accidentally do that. So then you just basically act like this is a separate problem. And you ask yourself, well, what's the GCF here? The GCF is x squared. And when I take x squared out from x cubed, I have an x left plus 3. And then over here, you have to take that negative out. If the third term is negative, you have to take a negative out, and the common number between these two is negative 4. So if I divide this term by negative 4, I get x, and if I divide this term by negative 4, I get positive 3. And so do you see how they both have the same term? So you can write that term here, x plus 3, and then you can basically think about it like this. This term is being factored out, so it's being removed, and what's left is x squared minus 4. So x squared minus 4 is your other factor. One thing that'll happen with factorizations quite often is you have to look at them and determine if they factor again. So you might have seen that up here and be like, does that quadratic factor? No, because there's no way to add terms of 9 to get 3. And you never have to worry about it with the cube rule, but with grouping, you have to worry about it all the time, that this actually factors again, right? So this doesn't, so it's x plus 3, but this other term will factor into x plus 2, x minus 2, because it's actually the difference of squares, you know, because 4 has factors of 2 times 2, and 2 minus 2 is 0, and there's no middle term. Let's take a look at another one over here, and this one's maybe more like the formula above. So if I split it in half, keeping this sign onto the third term, here I can remove a 5x, which would give me 2y. Be careful, we are dividing, so if you divide 5x and you divide a 5x here, it's very important that you actually know that that's 1, right? So here we take out a negative 4w because it's shared. If I divide this by negative 4w, I have, can't use the 4. Be careful of using the greatest common factor, which is this, you know, the number that they share. Unfortunately, that other term did not share a 4, so I got to backtrack, got to use a 2 there. So it's minus 2w. So if I divide this by minus 2w, I would get 2y. And I divide this by negative 2w, and I would get 1. And that's how you know you're doing it right, because you get the same thing twice. That's your first factor, 2y plus 1. And then your other factor, again, you can just scratch that out if it helps you. You can see it is 5x minus 2w. And those are my two factors. They don't factor again. And the way you know they don't factor again is there's no squares on those factors. All right, one more method, which is called the quadratic method. And the quadratic method is basically using the box method or area model in reverse, as we've already learned. So when you see something like this, here's the model you need. You need something that's a trinomial that is even, where the next term is exactly half that exponent. So notice I have a 4 and a 2, and here I have a 6 and a 3, half a 6 is 3. This would not work if this were a 4 and a 3. It doesn't work. This would not work if this were a 6 and a 4. It has to be exactly half the lead coefficient's exponent. And so it's pretty easy to factor this. What you do is, you draw your box out, all right? And when you get good at it, you can even do these ones with lead coefficient 1 without a box. And you say, okay, x to the 4th is locked in. How do I make that? Okay, that's going to be x squared and x squared. Negative 9 is locked in, and I got to use subtraction. So how am I going to get 8? Well, I'm not going to use 3 and 3 because that would, using subtraction, give me 0. So I'm going to use 9 and 1. And then I need to get negative 9, so one of these has to be negative, and it tells me here that I need the bigger one to be negative so that I can get negative 8. So now I can work it through. Negative 9x squared and x squared. These combine my like terms to give me the proper things. Everything checks out. So my factorization of this problem is x squared plus 1. Remember, if there's nothing on a number, it's positive. And then x squared minus 9. And then you say, does anything else factor? Now remember, the sum of squares does not factor, right? So that's x squared plus 1. But the difference of squares does, so this will factor into x plus 3 and x minus 3. All right, let's take a look at another one of those. And again, if you look at this and you say to yourself, I understand that it's 2 minus 1, you can just go right to the answer. The answer is x to the third power plus 2, and then x to the third power minus 1. You can do that by simply saying subtract the factors of 2, which are 1 times 2. 2 minus 1 is 1. I'm good. But let's take a look at the box method for those students who need a little bit more visual, and that's nothing wrong with that. Visualization is a great way to understand math. So this is locked in at x to the 6th. We know that we have an x to the third times x to the third to make x to the 6th, and that explains why the middle term has to be exactly half of the lead coefficient's degree, because of the fact that the first step makes you split it in half. Then we have a negative 2 here, which is locked in, and that can be made by 1 times 2, so I can put the 1 and the 2 anywhere I want. I'll make it 2 and 1. I need it to be negative, so if you can't quite figure it out, you can always put your 2 here and your 1 here, and then multiply through, and then say, okay, how do I get a middle term of positive 1? Well, if I'm going to combine like terms, this one would have to be negative. Okay, so that one's negative. All right, so that gives me the wrong answer, because when I put these together, I need a positive, so then you backtrack, right? So this is just the trial and error process that some students have to go through. We already know the answer. So then you say, okay, well, I put the negative on the wrong one because I checked it. So the negative must have gone here instead, which means the negative belongs there. And so now when you check 2x cubed plus negative 1x cubed, you do have positive 1. So if you need that extra support, use it. If you can go right to the answer, good. Now that being said, look at this problem. There's a cube right here that's a perfect cube. So yeah, you might have to use the cube rule to finish factoring. Luckily, there's no cube root of 2. So I'm not going to use the cube rule here. But in this problem here, you know, a is equal to x, because we have x times x times x. And here we have 1 times 1 times 1, and it's the difference of squares. So in this case, b is 1, and so I am going to now do the difference of squares, which the way that works, again, is a same. B squared opposite. AB always positive. And then I can plug the numbers back in. So A is x. This will be x squared. I have another x here. Then I have a 1 and a 1. Remember, it's multiplied. And then a 1 squared. And notice, I did this on purpose. Notice this is what happens to students. They do a great job. Remember I said originally that it really helps to put those parentheses in there so that you don't accidentally forget things like squares or multiplying, right? So those parentheses are extremely important. The students will get the right answer 90% of the time, but they forget little pieces like that, and then they get frustrated because they get the wrong answer, even though they really understand it. They're just kind of being too quick with the answer. So now that I've put the correct framework in there, I can get the correct factorization and rest easy with the cube rule. This will never factor again. 1 cannot be added to get a 1. You'd have to have a 2 there, so that will never ever factor again if you did the cube rule correctly.